So today we're going to look at lesson 5.5, Pythagoras Theorem, part 2. So in this lesson we're going to have a look at calculating the length of the shorter sides of a right angled triangle and how to solve problems using Pythagoras Theorem. Before we start then, let's just check our prior knowledge. So you do need to be able to calculate with square numbers. So I've given some examples there. You need to be able to calculate the square root of any number. You should know that squaring and square rooting are inverse operations and how to use them on your calculator. So again, if you've got your Casio calculator, this is your square root button and your square button there. Make sure you know where they are and how to use those. You should also be able to identify the longest side on a right angled triangle. So knowing that the longest side will always be opposite the largest angle, and the largest angle in a right angled triangle is that right angle there. So the opposite side is our hypotenuse. And you should also be able to rearrange equations and solve equations. Make sure you're happy with those before you move on. Okay, so in last lesson then we looked at finding the length of the diagonal and we used Pythagoras' theorem, which states a squared plus b squared equals c squared, where a and b are the two shorter sides of a right angled triangle and c is the longest side. So by squaring the two shorter sides and adding them, we get the square of the longer side. What we're going to have a look at today then is how to rearrange that theorem to be able to find either of the shorter sides, so either a or b. So remember, a squared plus b squared equals c squared is what we use to find the longest side. The longest side, our hypotenuse, is always called c. But if we want to find the shorter sides, we're going to rearrange this equation. So let's start off then by rearranging it for side b. Let's say I want to find the length of side b. So to rearrange it for side b, we simply need to take a squared from both sides. So remember, if I want b squared on its own, I need to get rid of the other things that are with it. To get rid of a positive a squared, I need to subtract it, but I need to do it to both sides. So we end up with b squared equals c squared minus a squared. So that's our formula for finding the length of side b. We also might want to find the length of side a. So again, if we start with Pythagoras' formula, this time then, if I want a on its own, I need to get rid of b squared. It's positive b squared, so we're going to take b squared from both sides. If I take b squared from this side, it will disappear, and I need to take b squared from the other side. So I get a squared equals c squared minus b squared. And that gives us our two shorter sides. The way it's labelled a and b here, it really doesn't matter which way round you label the a and b. C has to be the longest side, but a and b, it doesn't matter which one you call a, which one you want to call b. So in summary then, our formulae, a squared plus b squared equals c squared, our formula for finding the longest side. If I want to find a shorter side, then we start with c squared, the longest side, subtract a squared to give us b squared, or c squared minus b squared equals a squared. So remember, if I've got two short sides and I want something that's bigger, adding is going to make things bigger. So it makes sense to square and add the short sides to get the long one. If I want something smaller, a smaller side, subtracting makes things smaller. So starting with the longest side and subtracting the squares of one of the shorter sides will give me a smaller number. Okay, so remember they're all square numbers and we're adding if we want to find the biggest one and we're subtracting to find the smallest one. If you do get your subtraction round the wrong way, you will notice quite quickly because you'll end up with a negative number on your calculator. And you won't be able to square root that negative number. It will tell you it's a maths error. So you'll soon see if when you're subtracting you've got your numbers around the wrong way. So it's always the longest side squared, subtract one of the shorter sides squared to give us the square of the other shorter side. Okay, make sure you've made a note of that before you move on. So let's have a look then at some examples of how to find the shorter side. So as I said, it really doesn't matter with the short sides which one you call A and which one you call B. I'm going to call the one at the bottom A and the one at the side B. The diagonal, remember, is always C. So if I want to find this side here, which I'm going to call side B, I need to do c squared minus a squared. So c squared minus a squared will give me b squared. So c squared is my longest side squared minus my 6 squared, which comes to 13. So remember, that's the square of my new side. So I have to square root to find just b. So I square root 13, I get 3.6055 and some other numbers in my calculator. Remember, you have to write down at least 4 decimal places before you do any rounding. That will stop you from hopefully making any rounding errors. We're going to round it to 1 decimal place today. So x is equal to 3.6 centimeters. Okay, let's try the second one. So again, this time I'm still calling this one here B and this one here A. So I'm just going to use the other formula. So c squared minus b squared equals our a squared this time. Okay, so we're going to put in c, which is 14.5 squared, minus our b, which is 12 squared, gives us 66.25. Remember, that is a squared. So to find a, I need to square root this value, which gives me 8.1394, etc. And then I'm going to round it. And they've called it x, so I'm going to say that my answer x is 8.1 centimeters. Okay, the last one then. So again, we've got c and we've got a this time. We're going to find, I'm going to call this one b. Again, it really doesn't matter which one you've called a and b. It makes no difference to the short sides. So we're going to do 13 squared minus 6 squared, which is 133. We're then going to square root to find just b, which is 11.5325, etc. And we're going to round it to 1 decimal place, which means x is 11.5 centimeters. Once you've got your answer, don't forget to do a common sense check. So in our first one, our longest side was 7. So I know that the other two sides have to be smaller than the number 7, and they should be in relation to the other numbers here. So 3.6 is smaller than 7 and 6, so that seems quite reasonable. Here, my longest side was 14.5, so I need my answer here to be less than 14.5, which it is, 8.1. So again, I could see if I've forgotten to square root, then this can't possibly be my answer because my answer has to be smaller than 14.5. So when I say common sense check, it means to go back and look at the question and think, hang on, what type of answer should I be getting? And in this one, again, our longest side is 13, our smaller one is 6, and we've got 11.5, which seems a reasonable size between those two. All right, make sure you're happy with all of that. Then we're going to move on to your turn. There you are then. So you've got 3 similar questions there. You need to find the length of the missing side. Remember, if it's a short side, it doesn't matter whether you call it A or B, as long as we know that the hypotenuse of the diagonal is C. Okay, let's have a look at the solutions there. So we should have 4 squared minus 2 squared equals 12. Then we square root the 12, 3.4641, etc. to 1 decimal place, 3.5 centimeters. And we do our common sense check. It's got to be smaller than 4 and in relation to 4 and 2. So that seems reasonable. For this one then, our longest side is 6. One of our shorter sides is 3. So 6 squared minus 3 squared gives us 27. We square root 27 to get 5.1961, etc. And we round that to 5.2 centimeters. And finally, our third one then, again, there's our right angle. So this is our longest side opposite it. Our hypotenuse is 15. So we're going to do 15 squared minus 10 squared. Sorry, excuse that one there. Sorry about that. So as I was saying, 15 squared minus 10 squared equals 125. And the square root of 125 is 11.1803, etc., which to 1 decimal place is 11.2 centimeters. Make sure you're happy with your answers there before you move on. Okay, so we're going to have a look now at problem solving, so some real life situations where we might want to use Pythagoras' theorem. So our first one then, we've got a 10-metre tall flagpole is attached to the ground by a 17-metre long piece of wire. How far away from the base of the flagpole should the wire be anchored to the ground? So as always with these, I like to draw a sketch, okay? They will say a picture tells 1,000 words. It's much easier to see what I'm trying to find if I have a sketch of what it is. So we've got our ground there. We've got our 10-metre tall flagpole standing from the ground. And we've got our piece of wire going from the top of the flagpole to the ground, which is 17 metres long. We're asked how far away from the base of the flagpole should our wire be anchored. So we can see between the ground and the flagpole is where we have our 90 degrees. So opposite our 90 degrees is our C, our hypotenuse, and we've got the pole, so we need one of the shorter sides. So we're going to do 17 squared minus 10 squared, which is 189. Square root 189, we get 13.7477, etc. And we're going to round that to an appropriate degree, which is 13.7 meters. Okay, so just check with your rounding. It is down to you what you choose to round to if it doesn't ask you in the question, but 3 significant figures is quite normal. Okay, our second question then. A ladder of length 5 meters leans against a vertical wall. The foot of the ladder is 2.7 meters away from the base of the wall. How far is the top of the ladder from the ground? So again, I'm going to draw a sketch first to help me. Okay, there's our ladder. It's 5 meters long. And our wall here, and we are 2.7 meters away from the base of the wall. So the wall and the ground make our 90-degree angle, so our ladder is our hypotenuse, C this time. So we're going to do again C squared minus A squared, so 5 squared minus 2.7 squared is 17.71. Square root 17.71, we get 4.2083, etc. And we're going to round that again to an appropriate degree of accuracy. So I've gone again with 3 significant figures, so 4.21 meters. Make sure you're happy with those again before you move on. As I said, the sketch really helps. It helps us to see which sides we're missing, whether it's the diagonals or whether it's the shorter sides, so that we know whether we're squaring and adding or squaring and subtracting. Okay then, so 2 questions for you to have a go at. So again, pause the video, have a go at these 2 questions. Again, draw a sketch, it really will help you. Okay, so let's have a look at these ones then. So we've got our TV screen is measured diagonally from corner to corner. So a 65-inch TV has a width of 56 inches. We want to know the height. So there's our TV screen. Okay, it is measured, remember, diagonally. So screen sizes are measured diagonally from corner to corner, 65-inch TV. And we were told that the width was 56 inches. We want to know the height. Now, as our TV is a rectangle, that means we've got our right angle here in the corner. So we've effectively split it into a right-angled triangle here. So we can use Pythagoras' theorem. So again, we've got the longest side and we've got one of the shorter ones. We need another short one. So we're going to square and subtract. So 65 squared minus 56 squared equals 1089. Square root the answer. And we get exactly 33 inches. So our TV is 33 inches tall. Our second question then, a step is 0.5 meters high and has a ramp which is 3 meters long from the top of the step to the path. How far away from the base of the step does the ramp end? So again, a sketch will help us with this one. So there's our ground, we've got our step, which is 0.5 meters high, and we've got our ramp, which is 3 meters long. Our right angle then between the step and the ground, so again, we've got our hypotenuse C, which is 3 meters. We've got one of the shorter sides, we need the other short side. So we're going to do 3 squared minus 0.5 squared, which is 8.75. Square root the answer to give us 2.9580, etc. And again, we're going to round that appropriately, 2.96 meters. Make sure you've marked your work there and that you're happy with those answers. Okay, finally then today, we're going to do our challenge questions. So we've got some problem solving this time. So we're asked to calculate the length of the side of a square that fits inside a circle with a diameter of 12 centimeters. Pause the video, see if you can have a go yourself first. All right, so again, with problem solving, a diagram is really going to help us out. So we've got our circle, we've got our square in between, and we're told that the diameter of the circle is 12 centimeters. And remember, diameter is across from one side to the other going through the center. So there's our diameter of 12 centimeters. Now, if we've got our diameter of 12 centimeters, we can also see that that goes from one corner of the square to the other, and our square has a 90-degree corner. So again, we've created a right angle here. Now we know in a right angled triangle that the hypotenuse C squared is equal to the two shorter sides squared and added. So A squared plus B squared must equal 12 squared. Now because this is a square, if one side is A, then we can call the other side A as well. So rather than A and B, they're the same value. So we could say that A squared plus A squared equals 12 squared. Now if I simplify my equation there, A squared plus another A squared gives us 2A squareds, and 12 squared is 144. So whenever we're doing these sorts of problems, we need to break them down into our small steps. Now we're going to solve this equation. To be able to get A on its own, which is what we're trying to find out, we need to get rid of this multiplication by 2. To get rid of a multiply by 2, we divide both sides by 2. If I divide both sides by 2, I get A squared equals 72. Now we're going to get rid of the square. The opposite of squaring is square rooting. So I square root each side. I get A equals the square root of 72. The square root of 72 is 8.4852, etc. And again, rounded to an appropriate degree of accuracy, it is 8.49 centimeters. So the length of the sides of our square are 8.49 centimeters. Well done if you managed to get to that. Okay, thank you for working through this lesson today then. Next time we will be moving on to look at trigonometry.